Okay, welcome to chapter 19 and 20. So the first part is going to be on web hosting on page 674. So I know you guys have been to corporate websites, and so, if you wanted to have your own website, you do have some choices. I mean, you could host your own web page on your machine. That's probably not a good idea, and probably may even violate some terms of service from your internet service provider. Okay, I'm just saying. So most people put their websites on a hosted server someplace. So for example, I have 3 websites and I don't even know what state they're in. I don't know. Since I have no idea. Maybe they're in Indiana. I have no idea where they are. Doesn't matter. The majority of websites that you go to now are running Linux. So that's probably because Linux is free, and the web server called Apache is also free. So basically it costs you nothing to host, other than electricity to run the server, right? And you can probably imagine if you're a mom and pop operation, you probably only have one server, right? And if it's in the basement of the building or maybe hosted someplace, there's probably still only just one of them. But if you go to big companies, you think about Amazon. You think Amazon has one gargantuan server? Is that how they operate their system? No. They got lots of servers all over. And so having this operating at scale means you have multiple servers. And that's the cool thing about cloud computing, if we try this conversation back to a couple of lectures behind, is that, I'm getting an awful lot of traffic coming into my website and I want to have another web server. I can quite literally just clone that guy with a couple of clicks of the mouse, and presto changeo, I have 2 versions of the website up and running. Cool. All right. So the first thing we're going to talk about after that is the how it gets transported back and forth. So HTTP, the Hypertext Transport Protocol. Now this is one of those client-server type protocols. Where the client asks for something and the server says, "Okay, I've got that. Here it is." And all of the commands that you send are text-based, which is kind of odd. So HTTP is a text-based protocol for asking for things and getting things back. Kind of weird. The way it works is, I'm going to kind of halfway ignore some of the newer versions of HTTP version 2, so just bear with me. Typically, the way it works is one request gets you one thing. So if there's 4 things you want, you have to say, "Give me the first part." Okay, give me the second part. Okay, give me the third part. Okay, give me the fourth part. So there's an awful lot of chatter back and forth. Now, I'll confess there's a new version of HTTP that a lot of companies have not transitioned to. All browsers support the new stuff, where you can ask for multiple things at once, like a multi-request. But that's not really what we're talking about here. So in our world, as far as the textbook is concerned, it's one request gets one response. And if you want 18 things, that means there's going to be 18 requests for things. So this HTTP version 2 has been around since 2015, but still it hasn't caught on as well as you might think. But it does allow for you to bundle, or I guess it's a good term, bundle a request together saying, "Here are the 4 things I need." And the machine says, "Well, okay, here they are," and just start spitting them out. Okay. The next thing we're going to talk about is a URL, a Universal Resource Locator, URL. Now, in the world of web, basically, a URL is the thing that you type at the browser that brings you up a web page, okay? So there's kind of sort of okay, well, let me just get into it. So this is sort of like a map pointing you to a location. So it's like an address. If your address is 123 any street, you could kind of use that as a URL. So if I wanted to deliver mail to 123 any street, I would use the address. So the URL is the address. Cool. Now there's another thing called a URI, a Universal Resource Identifier. And quite frankly, a lot of people don't see this. If you're a programmer, you tend to see this a little bit more. Instead of having it being an address, it is a unique name. So in other words, instead of having it, 123 any street, it's going to be, Bob Q Public. And so I know when I send it to Bob Q Public that name is unique in the world. Okay. Again, most people don't see URIs. Hey, this is a good interview question because, not that these things really matter, but, interview questions kind of come up. Is every URL a URI? And it's like, wait a minute. So one of them is a locator and one of them is an identifier. They don't really serve the same purposes. But from a Venn diagram point of view, yeah, there is kind of an overlap. Okay. So typically when you see a URI, it's going to give you the what's called a scheme. Most people would say protocol rather than scheme. A scheme and then an address like HTTP something or HTTPS something. Or maybe you've even seen one that says email something. Okay, that kind of stuff. So let's take a look at an example of a full honest-to-God URL. All right. So this is kind of sort of important, hint, that maybe you should pay attention. So a scheme of some sort, there's lots of them. There's one of them is FTP. There's like, I don't know, a dozen of them or so. :// and then I'm going to skip over this username and password thing because, quite frankly, I don't think anyone uses that now because the stuff would be sent in the clear. Ouch. My username and password would be sent in the clear. Ugh. And then you have the host name. And then perhaps you have a port name because most websites are running on port 80. So typically you don't spell out :80, if not normally. And then the path. So the host name, this could be a domain name with lots of dots in it, like www.kumquat.com. All those are part of the host name. Okay. And then the path could be, images /ducks/mallards/mallard4. Okay. So the path could be complex. It could have multiple directories you have to go through until you get to the actual file itself. And I'm kind of going to ignore, for the purpose of this, ignore the fact that there's a query and an anchor. Okay. So let's talk about the www part. So most websites, for example, the www is kind of sort of optional. Let me give you an example. So I'm going to fire up a browser here, and I'm going to type in www.emmettgray.com, and up pops. Ta-da! Okay, let's do that again, except this time we're not going to do www. We're just going to do emmettgray.com, and it comes up exactly the same. So what's going on here? Well, in the beginning of the web, that first part of the domain name, like www-emmettgray.com, the very first part was actually the name of the machine. Server 4, okay, .emmettgray.com. That was how it was originally designed. You can probably imagine that that's probably not smart to give someone the name of your server. And so what they started doing is creating a server alias. And so instead of giving them server 4, it would be an alias. They would alias it to www. Okay? So www is typically an alias. And in most cases, the system is not even required. When I went to emmettgray.com, there's only one server there at emmettgray.com, and it's a web server. And therefore, I didn't actually need an alias at all. Okay? So the history of how that www got in there is kind of weird because it was olden days when you had server names and people don't like to expose their server names, and so therefore you use www instead. Okay. All right. The next thing we need to talk about is how the data gets transferred back and forth. I told you that the HTTP was a text-based client server kind of a thing. To tell you the truth, it's not a very robust language. Okay. It basically has about 6 verbs to it. That's it. I mean, this is not all of them, but as far as lecture is concerned, there are 6 verbs for getting stuff. Where I can ask for things, I can get the headings, I can get the deletes, I can post things, I can put things, and I can get some options. So basically, back and forth, asking for things, listing things, and sending you things. Okay, so the delete is typically not one of the things that gets honored. Now you could do this with stateful packet inspection. Yay, you guys remember all that, don't you? But since this is just a text-based protocol, it's actually just easier not to do it at the SPI level. Just go to the web server itself and say, look, we're not honoring the delete command at all, okay? That's just very, very typical. You know, when you set up a web server, out of the box, it probably has the delete thing turned off. Okay, what about this post and put stuff? Where I'm sending data. Do most websites allow me to send data? And you might think, well, heck no, that would be in violation of privacy. Yeah, they do. It's just the way the web servers work. Is like if I'm filling out a form and I type in my name and my address and state and I hit the submit button, it's sending that stuff it's sending a copy of the web page to the web server. Now it sounds a little strange because you might think, why am I sending a copy of the web page to the web server? The web server already has the web page, but that's just the way it works. So yes, the post and put kind of things are indeed allowed on most websites. Okay, let's take a look at what kind of responses that you can get back. Now this is an abbreviated list. There's quite a few of these things, but generally speaking, some of the more common error codes are done by category. If the error code starts with a 1, then it basically means, hey, I've got your request, everything's okay, but I'm telling you I'm doing something different. Like I'm switching, in other words, you asked for an HTTP, but I don't do that anymore. I only do HTTPS, and so it'll send a 100 something, 108 or 104 or whatever the number would be, to say, hey, I'm switching to a different protocol. Okay, it's not a problem. It's not an error. And then code 2 is basically everything's okay. Like, hey, I asked for this and I got it. Thank you. Okay. 4 means something's going on. For example, I asked for something and that thing has been moved to a new location. So yeah, that's kind of bad. What you're supposed to do when you get a 300 request is you're supposed to say, aha, that URL that I got is bad, and so therefore I probably need to go fix it. But most people don't. Most people just say, hey, I got to my page I wanted, so everything must be hunky-dory. When in reality, if you got a 300, you probably should say, well, you got there, but only under the good graces of somebody mapping the incorrect location to the new correct location when things move. Okay. 400 is one of those things where an error has occurred. Everyone knows 404 error is not file, not found. That thing isn't there. And then, of course, 500s is something's gone wrong at the server, and you probably have no way of fixing that. Some sort of a server, like, I don't know, the services have been turned off, or you run out of memory, or God only knows what. Lots and lots of stuff in there. Okay, so what we're going to do is we're going to install a very, very simple URL web utility called curl. Okay, so curl is not really a web browser, okay? Curl is like a probing utility. You can't use it for browsing because you have to know exactly what you're asking for, okay? So first thing I'm going to do is do an install. So it's pretty straightforward. It's going to be a sudo apt get install curl. Let me try that again. Spell curl correctly. Okay. Okay. Curl is already there. Okay, I didn't actually need to install it, but that's okay. It's good practice to know how to do this. Okay, we're coming up on the 15-minute mark, so you know how this works.